I know that you guys think sometimes that when you come to see me in office hours, you're really imposing upon me. People apologize for coming to office hours and things like this, but I really don't want you guys to think that, because office hours are here for you to come and get better understanding. And I enjoy interacting with students, but one of the things that office hours does for me is it helps me become a better teacher, because I sometimes figure out different ways of explaining things to students, because everybody needs sometimes a different way of having something presented to them. So over this past week, I talked to students about the competition equations and the graphs, and in the process of this, I learned for myself 2 new ways of kind of thinking about this. And so I thought it would be beneficial to you to see these things. So what I've done is I've set up stable coexistence, and I've kind of deconstructed the graph into all of its little component parts. We have the 0 net growth isoclines for species 1 and species 2. We have the directions that species 1 and 2 are moving. We've got pluses and minuses to indicate where populations are increasing and decreasing. So one way to think about this in stable coexistence is we have carrying capacity for both species is relatively low, and it takes quite a few individuals of the other species to drive, for example, species 1 to extinction. And these are the conditions under which stable coexistence occurs. A population limits its own growth more than it is limited by the presence of the other species. Well, one way to think about this is forget about species 2 for the moment and just think about species 1. If species 2 weren't around, species 1 would have a carrying capacity, that is where I plotted it, and the 0 net growth isocline would be located right here at carrying capacity for species 1. What that means is that if you're to the left side of the carrying capacity, if you're below carrying capacity, if you're between 0 individuals of species 1 and k individuals of species 1, what that means is that on this side of this line, you are experiencing positive population growth. And over here, where you're above carrying capacity, you're experiencing negative population growth. And in a similar way, we would look at species 2 and say, well, what would species 2's carrying capacity be if species 1 weren't around? And it would be right here. And if species 2 is between 0 and carrying capacity, it is experiencing positive growth. And if it is above carrying capacity, then it is experiencing negative growth. And so what's happening, if the 2 species were not in competition with one another, this is what the graph would look like. And the 2 species would basically grow to their carrying capacities, and if they ever crept above their carrying capacities, they would return to carrying capacity. And so when we think about populations, we would think of population 2 below the graph increasing, or below the line increasing, and above its carrying capacity it would be decreasing. And in a similar way, species 1 below its carrying capacity would be increasing, and species 1 above its carrying capacity would be decreasing. And this would be the situation if the 2 species were not in competition with one another. But what happens during competition is that species 2's presence basically takes species 1's carrying capacity and reduces it until finally there are so many individuals of species 2 that species 1 is driven to extinction. And in a similar way, species 1 reduces species 2's carrying capacity until it finally drives species 2 to extinction. And now we can get rid of all of these values here, or we can put them in the proper place. Let me tilt this and put this over here. Let me tilt this Oop, picked the wrong thing to tilt. Let me tilt this and put this over here, and then I would have to tilt this and put it under here, and I've already started tilting this, and that would go right there. And so this is how we get at these 4 points and why the 4 points end up being what they are. So I'm going to remove these pluses and minuses just to get them out of the way, because there was a second insight that a student helped me realize, and I had never thought about this before. But when you think about this being stable coexistence, species 2, if you think about species 2, this is the carrying capacity of species 2. This is the number of individuals of species 2 that drive species 1 to extinction. This is the carrying capacity of species 1. This is the number of individuals of species 1 that drive species 2 to extinction. But because this carrying capacity is lower than that value there, species 1 can never get big enough to drive species 2 to extinction. And species 2's carrying capacity limits its growth to the point that it can never get big enough to drive species 1 to extinction. And so these two species really don't have any choice but to exist at stable coexistence, because neither of them has a carrying capacity big enough to drive the other species to extinction. So this is just another way of kind of thinking about this idea of species competing with one another. If this helps you in a way that the way I went through it in class did not help you, great. If it doesn't help, then go back to the way that we covered it in class. So anyway, once again, come to my office hours. I'll help you understand things, and sometimes you will, even though you're not trying, help me understand things in ways that I hadn't understand them prior to having a conversation with you about it. So hopefully this helps you understand competition models a little easier, and hopefully it's useful too. Catch you in class.